guest is Dr. Jawhar Ibrahim. Sir is going to deliver the lecture on usage pattern of veterinary medicine products in Indian agriculture. Sir, you are audible. Your presentation is visible. Please continue.
Okay, thank you very much. And respected participants and the respected the organizers of three institutions, the Rajasthan University of Veterinary and Animal Sciences, Rajivas, Bikaner, Kerala University of Fisheries and Ocean Studies, Ufos, Kerala, and the National Agricultural Development Cooperative Limited, NADCL, Baramulla. So these three institutions have been organizing jointly the National Refresher Course on current development in veterinary and fishery sciences. Okay, CDVFS 2025. And I'm happy to see many of the participants who was already been online to listen to the lecture allotted to me on the usage pattern of veterinary medicinal products in Indian aquaculture. And before going to the details, okay, let me give some brief insight in my profile. Okay, I am Dr. T.J. Abraham from West Bengal University of Animal and Fishery Sciences. And I work as a professor in this university in the Department of Aquatic Animal Health. And we have been working on fish diseases, surveillance of the diseases, and the drugs, and that are being used in aquaculture as a national perspective. And I am in this institution for about 30 years, 27 years precisely. Okay, and before coming to these institutions, I was in Tanuvas for about 10 years. Okay, and you know that an aquaculture is one of the important aspects of animal food production sector, and it has been growing tremendously over the years to cater the needs of animal protein requirement of the fish lovers, particularly animal protein lovers. And if you can, okay, my topic today is on a little specific, and this is regarding the usage pattern of veterinary medicinal products in Indian aquaculture. Now, possibly you might have heard much discussions regarding aquaculture and veterinary sciences, both in details. Okay, possibly you are in the fag end of another 2-3 days. Okay, you'll be completing the program, and hopefully you are in the fag end of this program. And let me go into the details regarding this. Okay, and this is regarding the aquaculture, and throughout the world, aquaculture is growing. Okay, and it is expanding and intensifying. And according to 2024 FAO report, if you can see, a large number of species from finfish, shellfish, from freshwater, brackish water, salt water. Total, approximately 730 species are being cultured throughout the world. Of the 730 farmed species, 17 were stable. Stable means, okay, so they were the most commercial one that represent about 60% of the global aquaculture production, while other species are of regional importance or local level importance. Possibly you can see some of the fishes are available here, both finfish and shellfish, and it may be some of them are native, some of them are exotic. Exotic means migrated from one country to another country, deliberately or illegally. Okay, or even you can see at the bottom of the central one, you can see that transgenic fish, and this also commercially available for human consumption in Canada. And apart from that, you have the left-hand side, you can see that crustaceans, particularly the shrimp, as well as the crayfish. Okay, so this comprises some of the important species of aquaculture. And when you are thinking about the aquaculture, and of course, in 2022, and the global fisheries and aquaculture production increased to 223.2 million tons, comprising 185.4 million tons of aquatic animals and 37.8 million tons of algae. And if you are thinking about the aquatic animal alone, okay, so that comprises around, and that went for human consumption, okay, that contribute about 89% of the total production. And the per kg consumption by an individual is works out to be 20.7 kg per capita. This statistics in 2024 FAO records. Okay, for the first time, aquaculture surpassed the capture fisheries in aquatic animal production with 94.4 million tons. That represents around 51% of the total aquaculture, total fish production in 2022. That means, okay, all along capture, we have been depending on the capture fishery. That means the wild population that are available in the natural water bodies or the sea that have been captured and supply that we have come into the food chain. But in the 2022, okay, so we can see the tremendous growth in the aquaculture, and it has surpassed the capture fish production. And most of the aquatic animals are coming from the Asian countries. For example, 70% of the aquatic animals are from the Asian countries, and followed by Europe, Latin America, and Caribbean, 9% each, followed by Africa, North America, and Oceania. Oceania is in Australia, so it comprises around 1%. And among the Asian countries, the major producers are China, India, Indonesia, Vietnam. They respectively contribute around 36%, 8%, 7%, and 5% of the total production. And apart from that, you have some contributions, around 3% of the contribution from the Peru, which is a Latin American country. And this is about the aquaculture. And aquaculture, of course, it has got a history of around 4,000 years ago. It started in Egypt and percolated into many other countries. Okay, it started with the extensive level. Now it has grown up. It is exploded into the intensive or super intensive level. As far as aquaculture historical development is concerned, and in 1960s, aquaculture was in sustainable level. In 1980, it has grown tremendously, but problems started. In aquaculture 2020, okay, it is still okay. It is exploding level. Okay, so the many of the problems have arisen because of the intensification aquaculture practices, and currently it is aquaculture now in throughout the world. Okay, so possibly you can see that. Okay, you have seen the 224 million million tons of aquaculture productions have been reported, and it is exploding and intensifying. And several problems have been reported, but one of the major problems, and of course, on the right hand side, if you can see the green bars are available. Okay, so different parameters have been given, okay, contributing to the economic loss. Okay, and among the economic loss, the major problem is due to the major problem and the biggest challenge in the shrimp aquaculture industry, or in general, the whole aquaculture industry. It is based on the reports from the Global Aquaculture Alliance whole survey program. Whole refers to the global outlook for aquaculture leadership. They identified that based on the survey carried out in 2017, based on the issues and challenges in particularly in the case of shrimp aquaculture, as well as other countries, they have found that this is the major contributing factor leading to the greater loss to the aquaculture operations. So let me go into the details regarding the economic impacts of the diseases throughout the world as well as in India. Let me go into the details regarding, of course, if you can scan the literature, you will be getting thousands of literatures regarding the economic impacts of the diseases. But let me narrow down to World Bank report. In 1997, the USD, 3 billion per year loss has been reported in terms of United States, America, dollar, the USD. And in 2014, it increased to more than 6 billion per year. And in 2023, and more than 10 billion US dollars have been lost due to diseases per annum. Okay, and the bottom one you can see here that how the different networking of aquaculture activities are available. Starting from the farming level, the farmers and hatcheries, exchanges, and different allied industries. So they have been losing the valuable the profit or the revenues from the aquaculture industry. It's not only the aquaculture industry, okay, the allied industry have also been crippled due to the diseases. And as far as India is concerned, and we have very recently, we worked out that that estimated annual economic loss to the Indian aquaculture works out to be 18,304 crores, and which works out to be 14.9% of the production value. And in terms of employment loss, it works out to be 1.65 million man days, and roughly equivalent to 7.07 million US dollars. Okay, and the major diseases are due to EHP. EHP stands for Enterocryptozoan hippocampi. Then WSSV, this refers to white spot syndrome virus. Both of them are in shrimp aquaculture. One is the EHP is a fungus, okay, whereas WSSV is a viral diseases. Okay, and all along, before that EHP outbreak, and the Indian aquaculture has been losing good amount of money due to viral diseases. But for the past few years, we have been experiencing losses mainly due to the EHP. And for that, there are not many good management practices are available, and these farmers are continuing to lose a good amount of money on this one. And of course, the key factors driving the economic sustainability of the aquaculture sector is the culture intensification and culture intensification with improved germplasm and the better management practices, and that has been supported by our subject of discussion today, that is the judicious use of chemicals, biological and veterinary medicinal products, and that is broadly called as VFPs. They are the driving factors for the economic sustainability of this program. And we are going to discuss regarding the VMP. We must know what is VMP. And the VMPs are nothing but, it is also, the VMPs are nothing but veterinary drugs or medicinal products for veterinary use. And they are substances or combination of substances intended for animals, including aquatic animals, to treat, prevent, or diagnose the diseases, or modify the physiological functions, or for even anesthesia. And as far as aquaculture is concerned, more than 400 pharmaceutical companies producing over 4,000 different aquaculture healthcare products and chemicals have been registered in India. Of course, this is one of the part of the regulations for the use of aquaculture drugs and the chemicals in Indian conditions. And we have an organization called Coastal Aquaculture Authority, and they excuse me. They direct the pharmaceutical companies to reduce to register the products meant for aquaculture, and only the registered products can be utilized by the aquaculture operation. But during the registration, they see that no antibiotics incorporated compounds are registered. But that is the regulations by the Coastal Aquaculture Authority, that is broadly abbreviated as CAA. Is a government of India organization, and it has been established based on an act, Coastal Aquaculture India Act, and it has been amended very recently. And with the increase in farming industry, I was telling about that farming aquaculture sector, it is increasing tremendously and exponentially. And because of that increment in the farming activity, it has been predicted that that antimicrobial use may increase in global aquaculture by 33%. So this was about the 2020 report. And in the international trade, of course, you can know that, you may be knowing that, okay, most of the shrimps which are cultured in India and are exported, and the quality of this one is very important. And as per the WTO agreement, okay, so we have to go for sanitary and phytosanitary measures. Okay, and in terms of international trade and this seafood safety as well as sanitary and phytosanitary measures play a greater, they determine the market accessibility of fish and fishery products, particularly aiming at international export commodities, particularly shrimp. And of course, I was telling about the regulations. Okay, in terms of regulations, so several countries are imposing different quality criteria, and because of the quality criteria, okay, many of our Indian commodities have been refused. And say, for example, that average Indian shrimp refusals at the FDA stands for Food and Drug Administration due to the chemical combinations, and it was works out to be 16.65%. and which includes many of the veterinary drug products. That's one of the criteria which we have been looking at. And this is regarding USFD. This is regarding United States of America. Not only in the United States of America, in the case of European Union, under the umbrella of Food and Veterinary Office, FVO missions, and that is responsible for ensuring the quality compliance of fish and fishery products imported into the European Union. And because of the data on the usage pattern of the chemicals, because that's what the topic is, they decide based on the usage pattern of the chemical, particularly veterinary medicinal products, and more particularly the antimicrobial agents that are essential for the FEO to take informed decision on the safety of seafood imported into the EU from India. So as a result, what is happening is that there is an increase in the rejections in Indian sea market because of the increased rejection in Indian seafood, okay, due to the veterinary drugs or the veterinary drug residues, okay, that has resulted in increasing the border checks of consignment that is going from India. So say, for example, that earlier, before 2050, the check was around 10%. Now it has increased to 50% because of the increased rejection and increased prevalence of antimicrobial residues in the commodity. That means effectively every second seafood consignment from India is checked at the European Union border, leading to additional cost to the producers and the delayed delivery. Ultimately, the reputation of the Indian companies are being lost. Okay, this also lead to a decrease in the share of Indian frozen shrimp exports from India to the European Union. Say, for example, in 2016, it was around 22.2%. Now it has come down to 11.8% in 2022. So this has led to decrease in the share of Indian frozen and also the revenue to the foreign exchange exchequer to the Indian government. So that is the reason why we have been working on. Not we mean that government of India is working on the developing database on the usage pattern of the chemicals and VNP, and in terms of getting the primary production data, okay, that is required to comply with the international regulatory requirement of for the safety as well as the reputation of the traders, okay, safety of the consumers as well as the reputation of the industry. And in terms of monetary value, the rejected Indian seafood consignment to the USA, EU, and Japan. These are the three major importing countries from India that alone estimated to be between US dollar 35 to 40 million. So it is a huge loss for the foreign exchange exchequer. Now let us come to the subject and how that antibiotic or antimicrobials are used in aquaculture industry. In terms of method of application, many of the commodities, veterinary medicine products are used in aquaculture. And the right-hand side, you can see the method of application and the comments are given. And most of the antimicrobial substances are given through oral route, that is through medicated feed. And besides, you can see the bioencapsulation process, that is a process by which some of the live organisms can be encapsulated with the drug. Okay, and then bath treatment, most likely in the case of ornamental or smaller one, dip treatment, flush treatment, and injection, particularly in the case of and high value fishes like ornamental fishes or the brooders, or even the topical application. But the later part of this method of applications, except the oral route, it is very minimal. And if you can see that antibiotic usage in aquaculture, it is the range of aquaculture, the aquaculture use of antibiotic and antimicrobial, it is almost close to other food producing commodities that has been presented in the right-hand side. What you can see here, it's a report from Wageningen University in 2014. And if you can see the graph, okay, the Chile is the major country that use good amount of antibiotic for the production of aquaculture. And in terms of the quantity, it works out to be 701 grams of antibiotic to produce 1 ton of salmon, and which is far less than some of the countries like Scotland or Norway or even China. It comes around to 1.1, 1.3, 1.32 gram per ton fish production. But some other countries like Vietnam, Thailand, and as well as Canada, particularly the British Columbia, for the fishes like salmon, catfishes, and tilapia, and the use of antibiotics are quite rampant. And in terms of shellfishes, particularly China is the largest, Thailand is the largest producers in 2014, followed by China and Vietnam. And even smaller countries like Bangladesh and the bigger countries like India, no such reports were available during that period. But of late, okay, but in terms of compared to the other food producing animal, it is, of course, it is on par or below that level. And say for in the case of Netherlands, particularly the pigs, cattle, and poultry, okay, the range of antibiotic used per ton production is ranging from 122 mg to 368. And in the case of European Union, the whole of European Union, it was okay 144 gram per ton fish production. And of course, in the case of aquaculture, the use of antimicrobial in fisheries, particularly aquaculture, started with the work of Gutschall in 1946, but later it was suspended because later in parallel, okay, the works on vaccine also developed, but because of that, the beneficial effect compared to the vaccine, okay, so this was the use of antibiotics were quite rampant, and this antimicrobial, particularly the potential to sulfonamide, and that was used to combat furunculosis caused by Aeromonas salmonicida, and it was used at the dose of 22 gram per 100 kg fish biomass per day, and the treatment regimen is for 10 days, particularly in the case of Atlantic salmon, salmonella. Okay. And it was typically applied via medicated pelleted feed, and following the manufacturer recommendations. Okay, this was some of the part of regulations, paying close attention to the withdrawal period, feeding rate, and rations. Okay, and over a period of time, okay, so we have got several layers of regulations have been implemented in aquaculture. Okay, so that's the reason why we have different organizations in prescribing regulations, and one such organization is the Center for Veterinary Medicines, particularly the Office of the New Animal Drug Evaluation, (ONADI), and which is functioning with the different government organization and aquaculture association to raise the number of safe as well as effective drugs that can be used by the aquaculture industry. And this was the status before 2020, but currently United States Food and Drug Administration, USFDA, has approved antibiotics such as chlorphenicol, oxytetracycline dihydrate, sulfamerazine, and ormethophrim and sulfamethoxine. Okay, so these are the 4 antibiotics that has been approved for use in aquaculture for treatment of specific bacterial diseases in selective species through medicated feed. Of course, this follows certain regulations, and none of this antibiotic proposed here can be used for other than aquaculture, say particularly the terrestrial animals and even human medicine, because it is exclusively catering the needs of the aquaculture farmers and aquaculture commodity, and they periodically make reference guide regarding the approved drugs. Okay, how much to be used, what species to be treated, what disease to be treated, and how the drug regulations to be complied. Okay, so all these details are available, and such kind of informations are not available in India. So this is the need of the hour. Okay, possibly some of that aspects are available in veterinary medicines or human medicine, but in the case of aquaculture, the use of antibiotic, though it is not rampant, but such kind of regulations are not available. And apart from that, we have been working on, sir, you have a list of low regulatory priority aquaculture drugs that includes acetic acid, calcium chloride, calcium oxide, carbon dioxide, fuller's earth, tar lake like natural product, ice, hydrogen peroxide, magnesium sulfate, anion, propane, potassium chloride, and so many things are available. So these are all not approved, but they does not come under the major regulatory one. The farmers can use it, but for certain specific conditions at specific doses that has been prescribed. And apart from that, you have INADs, that is investigational new animal drugs. So that cannot be used unless otherwise, okay, it can be regulated. Okay, and then let us come to the subject. Okay, so as I was telling about the use of antibiotic or antimicrobial substances, particularly in Asia Pacific regions. Okay, so and if you can see the global scenario, okay, 93.8% of the total antimicrobial compounds are used in the Asia Pacific region. Of course, in the topographical area wise, okay, it is huge, and the usage is also huge. And China is the major contributor of that antimicrobial use, and they utilize about 57.9% of the antibiotic use in the global scenario, followed by India, which works out to be 11.3%. And since 2017, these two were the major countries, and they are the top countries using antibiotic agents, particularly in the case of catfishes, contributing around 8.3%, tilapia, shrimp, trout, and salmon. Of course, salmon is not common in the case of Indian conditions, and trout is a cold water species, particularly in the case of the Himalayan wells, it has been cultured. But catfish, tilapia, and shrimp, okay, and carps, these were the commodities that are cultured in the China as well as India. And the antibiotics such as quinolones, tetracycline, penicillin, sulfonamides, and microlide, they are the dominant group, and it has been utilized on a largest share. Okay, in terms of different antibiotics, share of the different antibiotics also to be in terms of percentage as well as the quantity used in the 2017 data. This includes quinolones, tetracycline, amphenicol, sulfonamide. Totally, it works out to be 10,259 tons to produce the total aquaculture commodities in 2007. And as I was telling about the prediction, okay, that based on that antimicrobial usages and intensification in aquaculture practices, and it is expected that okay, the antimicrobial use is expected to increase 33%, and that was the prediction. And most of the predictions are from most of the prediction and higher utilization, higher AMU use is from China, India, Indonesia, then Vietnam and Egypt. Okay, so this is based on the reports from available in scientific reports. Okay, by 2020, the prediction says okay, it may increase by 33%. And not only in these particular countries, okay, throughout the world, the antimicrobial use is reportedly may increase. Okay, particularly in the world, it may increase to almost around 35 to 40%. And then North America is the country where that increment is expected to be the least. And the case of Latin America and Africa, okay, it is expected to be tight. But Asian share, it is almost on par with the global share. Okay, so not only this, because this of course it is based on the report from the 2017, but even in many of the countries, okay, so even in recent days, okay, people are working on that the usage pattern of the chemical in order to as per the compliance of as per the directions of this one and the complying to that international regulations. And if you can see the right side bottom graph, okay, you can see Chile is the largest user of that antibiotic. Possibly, if you can work out, okay, it will be okay, from 700 gram, it has come down to 400 gram of antibiotic, okay, to produce 1 ton of salmon. Whereas in the case of salmon, they are the highest regulations in the aquaculture use of antimicrobial, and the use of antimicrobes are very much documented, and methodically they do the systematic regulatory measures, adoption of regulatory measures. Ultimately, it has come down to the lowest level. And this is regarding the use of antimicrobial in different sectors. In the case of aquaculture, the use of antimicrobial compared to the global scenario, it works out to be only 5%, 5.7% compared to 25.5% in the case of human and 73.7% in the case of terrestrial animal. And in the case of recent data, according to the WOAH, that is World Organization of Animal Health 2000 annual report, amphenicol, particularly the chlorphenicol, that contributed the highest consumption rate, also to be 48.31%. And other classes like fluoroquinolone, which was dominant in the case of 2017 data, it has come down to 21.3%. And tetracycline remains the third position, and followed by the sulfonamide group. And these are the 4 antimicrobial that has been approved for use in aquaculture. And in terms of the per kg production, that use of antibiotic ranges from as low as 0.73 mg to produce 1 kg fish to 1.265 gram to produce 1 kg fish. You can see that alarming level of use of antimicrobial commodities in the case of aquaculture fish production. So this is regarding this. I am going to talk regarding that India. India, as I said, okay, India is the second largest aquaculture producing country, following China. And China produces around 36%, whereas India produces around 8% of the global production. And so we were involved in the development of data on the usage pattern of the chemicals, biological agent, and veterinary medicinal products in Indian aquaculture. It is based on the survey. The survey were from in IMC, Indian Major Cause, Pangasius, Rainbow Trout, Shrimp, And throughout the world, we were able to cover around 2,936 farms and comprising all these aquaculture species. And the number of farms are given in the table. And we found, okay, some of the major common diseases in Indian aquaculture that include bacterial septicemia, bacterial gill disease, epizootic ulcerative syndrome, it's a fungal disease, columnaris, lactococcosis, ulcerative syndrome, white spot ick disease, and catfish septicemia, argulus, symphalicus, hernia, vibriosis, white spot disease, microsporidiosis. These are some of the common diseases that has been listed. And based on our survey, we found that and the Indian farmers have been using almost around 52 different types of chemicals, biological and veterinary medicinal products, and that we have classified into 9 different categories, and the quantification also worked out. Okay, but put together, and the Indian farming community has been utilizing around a total of 28.82 kgs of inputs. That inputs they listed below here. Okay, per ton fish production in Indian aquaculture production, particularly the which I have shown here, that IMC plus, pangasius, rainbow trout, and shrimp. So all these commodities, when we put together, that use of inputs works out to be 28.82 kgs to produce 1 ton of fish producers. And the dominant one is environmental modifiers, works out to be 22.82. The environmental modifier means when you go for deliberate addition of feed or other inputs into the system, environments get altered, and in order to modify that, we use different modifiers. And this followed by probiotics and nutritional supplements. And subsequently, we use disinfectants, antibiotic, antifungal, antiparasitic, natural anti-infective agents, and herbicides, particularly pesticides, are used. And all of them you can put together. It works out to be 28. Possibly, you may be surprised to know that okay, so that much quantities of different veterinary medicinal products are utilized in Indian aquaculture. Of course, this is a fact. And in terms of the percentage of farms or the farmers in different farming groups using these chemicals, the disinfectants were the dominant one among the one, apart from the environmental modifiers. And among the Indian farmers, 40% of the farmers were utilizing disinfectant. And the disinfectants are dominated by the potassium permanganate, contributed by 20% of the farmers. And the probiotics is the environmental modifier is the dominant one. 66% of the farmers are utilizing it, followed by the disinfectant, and that is followed by probiotic, comprising around 32% of the farmers. And the lime material, the environmental modifier, particularly adjusting the pH, the lime is utilized by almost around 33% of the farmers. And mineral as a feed supplement, it has been utilized by around almost around 18% of the farmers. And in terms of antibiotic, so almost around 12%, 12 to 12.6% of the farmers were confessed they were utilizing antibiotic. But in the case of antibiotic, so you need to understand that the antibiotic use, antiparasitic use is higher than the antimicrobial agent, because the Indian farming system are crippled by variety of the antiparasitic agents. Variety of antiparasites. In order to contain, the farmers are relying on many of the antiparasitic agents commercially available. And apart from that, so in this case, in the antiparasitic agent, the deltamethrin is the dominant one. And in terms of herbicides and pesticides, so 12.81% of the farmers utilize pesticides. And among the pesticides, the saponin, possibly in the case of West Bengal regions, the farmers utilize mahua oil cake. It's an oil cake that contains a chemical substance, saponin, and it has got a dual role. Initially, it serves as a fish controlling agent, pesticide agent, followed by a nutrient for fish as well as the aquaculture system. So this I have given an information regarding Indian conditions. So not only in India, several countries, like the smallest country, the Bangladesh, and the China, the largest country in aquaculture, the Thailand, and several aquaculture species, they have the data on the different trucks used per ton fish production. So it started in 2011 onwards. Vietnam, Norway, Chile, and India. So these are some of the countries. They have the report. Of course, all these are all based on the insistence from the international trade and their regulations, particularly the sanitary and phytosanitary measures. And this is what we have been discussing regarding the regulations of the chemicals and VMPs used in aquaculture. And it is based on the insistence from the WTO. Okay, the several countries have established mechanism to approve veterinary drugs. Of course, in India, this particular aspect has not come into play. But many of the developing countries are developed countries like USFDA, European Union, even China. Okay, so these are the countries where their approval or the regulations have been implemented. And in the case of USFDA, it is based on the Center for Veterinary Medicines. In the case of European Medicine Evaluation Agency and EMA, they regulate and license or authorize the drugs for use in aquaculture, particularly the countries within the EU. And Australia, possibly many of the members are aware that Australia is one of the stringent country in terms of surveillance and the regulations. Okay, so they have the Commonwealth Agricultural and Veterinary Chemicals Act, and it was amended in 2005. And they coordinate everything through Australian Pesticides and Veterinary Medicines Authority. And such kind of authorities are available in Canada, Chile, Brazil, China, Vietnam, and Asian countries. And in the absence of such regulations in Indian condition, so the government of India has made an act so to implement such kind of generally overseeing the regulatory measures. CAA has been established under the Ministry of Fisheries, Animal Husbandry and Dairying, and MPDA is the Ministry, and MPED, Marine Products Export Development Authority, under Ministry of Commerce and Trade. So they publish the list of antibiotic and other pharmacological substances that are restricted for use in aquaculture. And simultaneously, we have certain aspects of regulations under FSSAI, that is Food Safety Standards and Standards Association of India. So it has fixed an MRL level, that is maximum residue level, for few antibiotics like oxytetracycline, oxalic acid, and sulfate, some of the sulfates. And this is regarding the key regulatory bodies that has been controlling that chemotherapeutic agents for use in aquaculture, particularly Africa. It is not now. No such regulations are available. And Asia, few countries have regulations like Vietnam and China. And Australia, very good regulations are available. China, approved drugs are available. And Europe and USFDA, they are the two major organizations, and they have the stringent regulatory measures on the use of one. And particularly in the case of India, the Coastal Aquaculture Authority, Central Drug Standards Control Organization, that is CDSCO, they have a special cell to monitor the veterinary drugs, vaccines, and matters, particularly related to that aquaculture. But they are not that much shrewd as in the case of USFDA and USA. And okay, so why we should go for the regulation? What are the key objectives? If one has to understand. It is primarily aiming at food safety, because whatever commodities which produce, everything goes for the human consumption. In the few earlier slides, we have seen 89% of the aquaculture products are going for human consumption. Ultimately, so we have to think about the safety of the consumers, okay, particularly the harmful drug residues and in aquaculture product that could pose risk to human health, particularly in terms of antibiotic resistance, inducing antibiotic resistance or allergic reactions or toxicity related problems in the case of the consumers. And also when you are adding antibiotic, it may be leached into the environment. That may impact the environment. So particularly the aquatic ecosystem, and in terms of development of antimicrobial resistance in environmental bacteria as well as human pathogen, and even it may harm the non-target organism other than fish. Okay. And the third objective is the animal health and welfare. So we have to ensure the drugs that are used in aquaculture must be used appropriately to treat diseases, and it should promote the health of the farmed animal by preventing the unnecessary use, and it should not affect the non-target organism. And the major barrier here is that one of the major objectives is the trade and market access. And we have to have that the meeting of international standard and the customer expectation. The customers are very much very stringent, and they are very much conscious about their health ultimately. So we have to fulfill their expectation regarding the safety and the quality of the aquaculture products for domestic as well as international market. But we are not bothered about the domestic area. In particular country, in some other pocket cities, okay, may have looked into the domestic markets, have got certain regulations, but in the case of international regulations, okay, unless otherwise it complies to the regulatory measures, it cannot be sent to the foreign countries. Okay, what are the approaches? Okay, so in the case of aquaculture, any drug or any chemical or any veterinary medicinal products used, that must be an approval process. For that approval process, we must have a data on the safety of the commodity. Risk must be assessed, and the labeling requirement, how much to be used, okay, which fish to be used, with bacteria to be treated, and what dose, and what would be the withdrawal period. All the data must be available in the label. Okay, and we must have the database on the banned and restricted substances. Okay, as far as India is concerned, we have only the banned and restricted drug. That does not mean that, okay, we should use only that. This cannot be used, okay, whereas all other drugs can be used. It is not so. Okay, so we need to have some kind of regulations to be used in aquaculture system. And again, the major one is that the regulations mandate involves the withdrawal, establish the withdrawal period for each of the antibiotic or the drugs which is used in different aquatic animal species. In the first slide, we are seeing, and throughout the world, we have around 730 fish species, and the withdrawal must be established for all the species because every species are different. Okay, because they have the different metabolic activity, different physiological activity, different food and feeding habits. Okay, it must be safely established for different species. And again, the veterinary oversight. In many countries, prescription and the use of certain aquaculture drugs require veterinary supervision. Of course, it is not available in Indian condition, particularly if you can go to the Norway without the veterinary prescription. Okay, no antibiotics should be asked, and every drug which is used in Norway aquaculture condition must be documented and entered in the system. The next one is that monitoring and surveillance. The regulatory agencies often conduct monitoring program to check for drug residues in aquaculture products and to track drug usage pattern. So this is what important in the regulations. Okay. Then another thing is that they advocate good aquaculture practices in order to reduce the antimicrobial use in aquaculture system that we call GAP. The regulations must promote that mandate adoption of good aquaculture practices that emphasize disease prevention. So that the emphasis should be on the treatment of the diseases. That okay, before the disease comes, okay, we need to address the measures to prevent the diseases by following biosecurity principles and the responsible use of drugs to minimize the need for treatment. Then again, the major problem in aquaculture is that okay, the extra label use of antibiotic, particularly some other antibiotics like quinolones, particularly enrofloxacin, which is quite commonly available in veterinary side, and it must be used, though it may be used with the veterinary prescription, it has been rampantly used. Firstly, if you can see the earliest table, in Indian condition, almost around 3.41% of the Indian farmers are utilizing and the enrofloxacin, which is not supposed to be used in aquaculture because it is classified as the critically important antimicrobial group, that is quinolone group, or as a human medicine. But this enrofloxacin can be used in veterinary medicine, but still, okay, because of its easy availability, they use it. Okay, but it requires the regulations by through the prescription of the veterinarians. Okay, but that is not being followed in this one. Then another major problem in the drug approval is the environment impact assessment. Before that approval process, the drug must be assessed for its safety on the environmental aspects, particularly on some of the indicator species to be assessed, and its toxicity mechanism to be explained, targeting the non-target species. And what are the challenges we face in aquaculture drug regulation is that, okay, as I said, we have a diverse species, almost around 730 species, and different farming system from freshwater, brackish water, and different culture practices, extensive type to super intensive type, and the limited availability of aquaculture drugs. As I said, okay, we have only 4 drugs. Some other countries like China, European Union, oxalic acid, or some of the quinolone compounds have been approved for as a secondary treatment. In China, few other chemicals, few other antibiotics have been recommended, not approved. They can recommend with the supervision of the veterinary medical practitioners. And extra label use of this antibiotics is one of the major regulatory complexity, which leads to major regulatory complexities because of its easy availability and its potential risk if not managed properly. And then enforcement of the regulation and its compliance are across the country is very difficult because of the diverse aquaculture operations. Okay, so that makes the process very difficult. Then again, if you can see that regulations in different countries are not the same. Okay, see, it varies. Say, for example, US FDA, you have only 4 antibiotic and few set of non-regulatory, non-priority drugs. Okay, whereas in the case of China, many such compounds are there. Because China, obviously, they are the largest producers of aquaculture species. Obviously, they have to go for this one. Again, the major problem here is that the emerging diseases. And every year, every culture operations, okay, you can see that occurrence of emerging and re-emerging diseases. Okay, so that is crippling the aquaculture activity. Okay, so emerging diseases is one of the major problems in the case of aquaculture. The farmers have to cannot understand what kind of chemicals or what kind of drugs to be used for aquaculture operations. Okay, this necessitates that ongoing research and potential development, new treatment, the regulations. Okay, so this need to be taken care. Okay, so these are about some other aspects. This one, then let me go for the conclusion. And after the conclusion, we can have some kind of discussion with the members. Okay, so one of the important thing is that, okay, so in India, as far as India is concerned, we have been using different type of chemicals, biological veterinary products, which increases the aquaculture intensification. And when compared to the different aquaculture producing countries, the use of antimicrobial agents in Indian aquaculture was much lower than the global scenario. And of course, India must develop regulatory guidelines for use in the aquatic healthcare products for sustainability, as well as protect the consumers. Okay, we need to go for the mandatory registration and authentication of the PMPs, as well as the biological, particularly the vaccines. Okay, so we need to have a detailed laboratory and field level data on fish as well as animal safety, particularly its efficacy and withdrawal period, which is not available in Indian condition. Because say, for example, whatever withdrawal period on different species are available for tropical, not for tropical fishes, it is all temperate fish. Temperate fish means cold water fish. You know that metabolic activity differs from the species to species and temperature to temperature. Okay, so metabolic activity is less in the case of temperate fish, whereas it is fast in the case of what? In my experience and in many of the literature experience. Yes, please. Yes, okay, it is fine. Okay, so we need to go for the last one. Okay, the withdrawal period. That may vary. So we need to focus on the research and development and effective pharmaceutical compounds. Okay, since 2019, no antibiotics have been available for treatment of the many of the diseases. Okay, again, the disease burden is increasing in different countries. Okay, so we need to go for increasing the diagnostic capabilities of different laboratories. Then fewer vaccines are available. We need to intensify the vaccine development, and we need to go for creating awareness on occupational health hazards and several training programs that we conducted as it is being done today on this use of drugs. Okay, so of course it need to percolate to at the farming level, particularly among the awareness among the farmers on the merits of chemicals as well as VMPs. Okay, so this is the last slide. Okay, so we have the regulatory authorities, but we need to have a stringent mechanism that is being followed as it was followed in Norway, and still they have been following. Okay, possibly you can see the blue graphs. So it was the use of antibiotic. It was rampant in 1997. It was the highest. Possibly it was around 454 grams of antibiotic they have been using to produce 1 ton of solvent. Now it has come down to 1.3 gram to produce 1 ton. So that was the level of regulatory measures they had. So they have gone for higher higher level of application of vaccines. So they intensify the research on vaccines. So now the antimicrobial use has been reduced by 99.3% from 1991 to 2008. So such kind of regulatory measures we require. And in the case of US, and the regulation says, okay, so 70% of their animal antibiotics are only class antibiotic, particularly tetracycline. Such kind of antibiotic alone we should use for animal sciences, not for human sciences. Okay, but overall, in the global scenario, so the agriculture, particularly aquaculture and animal husbandry, are the well-performing food producing sectors compared to the human sector. Okay, so the use of antibiotic because of the regulations is over a period of time is coming down. Okay, so with this, let me conclude. So let us think about judiciously utilizing the aquaculture resources or the natural resources for the betterment of the human and the human safety. So thank you very much for the patient hearing. And if you have any clarifications, now we can discuss for about 10 minutes. Any doubts, friends? Friends, the deliberations are welcome.
Hello, participants. If you have any questions, please ask.
Possibly everything is clear to them, if I'm correct. There are almost around 35 members other than me. And I could see many of the